This topic looks at stoichiometric coefficients. So the question says, what is the total number of oxygen atoms on the right-hand side of this chemical equation? So let's look at the chemical equation and see if we can figure out what is what. So it says we're looking for oxygen atoms on the right-hand side of the chemical equation. What is the right-hand side of the chemical equation? Well, it's going to be everything to the right of this arrow here, this yield sign. So this is the left-hand side of the chemical equation. This would be the right-hand side. And the atoms that we are looking for in particular are oxygen atoms. So let's identify all of the oxygen atoms. There's an oxygen atom. Here's oxygen. Here's oxygen, and oxygen is also present here as well as here. So we see that oxygen is present in almost each substance, or as a matter of fact, in every substance on the right-hand side of this chemical equation. So we call these the products in this particular reaction. Oxygen is present in this product. It's also present in this product, in this product, and in this product. So how do we calculate the total number? Well, we need to calculate the number of oxygen atoms for each substance and then add them all together. So let's look at this substance first. Okay, this product. How many oxygen atoms are in this product itself? Well, let's look. There's a subscript here of 1, even though it's not written. But this oxygen is in parentheses with an additional subscript to the outside of that. So this 10 is going to apply for both of these atoms, for the carbon and oxygen atoms. So 10 times what is already here, 1, would mean I have 10 oxygen atoms. So I have 10 oxygen atoms in that product. Now, before we move on to the next product, to find the total number of atoms, of oxygen atoms in this one particular product or substance, you always have to multiply the number of atoms by the stoichiometric coefficient. The question is, what is the stoichiometric coefficient for this substance? There's a 1 here, is it not? So there is a 1 here. It's not written, but it's assumed to be a 1. So total number will always be the number of individual atoms multiplied by the stoichiometric coefficient. The number of oxygen atoms we have in this one product is 10. Multiply 10 times 1, well, that's still 10. So our total, let's write our total in green, would be 10. Let's move on to the next substance. So we have one substance here, one substance here. Here's another product. Here's another product. If I look at this potassium carbonate, K2CO3, there's the oxygen. How many oxygen atoms do I have? 3. So I have 3 oxygen atoms right there. Total number will be 3 times the stoichiometric coefficient, which again is 1. So 3 times 1 would be 3. Let's go over here. We have oxygen present in multiple places in this substance, but that's okay. We just add them together and then multiply by the stoichiometric coefficient again. Here's 1 oxygen atom plus another oxygen atom would be a total of 2. So 2 times 1 again gives me a total number of oxygen atoms for that substance in this reaction, 2. Over here in water, I have 1 oxygen atom. 1 times, again, we have 1 as the stoichiometric coefficient, would be 1. So my total number of oxygen atoms is 1 for that product. So to finish up, all we have to do is add all of these numbers together. and then we will have our total. 10 plus 3 is 13, plus 2 is 15, plus 1 is 16. So that means that there are 16 atoms of carbon on the right-hand side of this chemical equation.